So what we find is chapter 12 introduces us to the idea of equilibrium. Well, we've already been introduced to this. The idea that we had earlier on was you have an object, it's hanging by some tension. We got mg pulling down. Equilibrium says force up equals force down, so the tension equals mg. So we've been doing this. The difference is that we now define two types of equilibrium: translational and rotational. For translational equilibrium, the sum of the forces equals 0. And this would be all the forces, x, y, and z. For rotational, the sum of the torques equals 0. And so that means that for translational equilibrium, this means that the acceleration is 0. For rotational equilibrium, it means the angular acceleration is 0. And so that's the main thing here, is we're now adding the idea of rotational equilibrium. We've been talking a little bit about translational equilibrium for some time, but now we're going to introduce the idea here of rotational equilibrium. Now, this leads us to static equilibrium. Static equilibrium requires that the sum of the forces is 0, and the sum of the torques is 0, and the velocity is 0, and the angular velocity is 0. In other words, it's in equilibrium and it's not moving. Okay. If we take away these two constraints right here, if we don't have those, then that would be dynamic equilibrium. So dynamic equilibrium is a little bit less restrictive. Here, some of the forces is 0 and some of the torques is 0, but it could be moving. It could be rotating, or it could be translating, or it could be doing both. And so that would be, for example, something like an aircraft in flight would be in dynamic equilibrium. Okay. So that's the basic idea right there. That's equilibrium, and so next we're just going to do a few examples of equilibrium.